Dear students, in this video we will study the laws of refraction using Fermat's principle. Again, I will take you quickly through this Fermat's principle. It states that when light passes through a medium or a set of medium, it follows a path which is shortest, or the path which takes the shortest time. I have already explained this to you, that it is very logical to understand this law as long as the medium is homogeneous. But if the light has to pass through a number of medium, and obviously those mediums will have different properties, different optical densities, so light will not be traveling in straight line, but it will be bending frequently one after the other medium. So in that case, a better way of writing this would be that total path is mu times ds dash, integral from some point A to some point B, but optical paths will be added up, and I have already told you the difference between optical path and geometric path. Okay, geometric path is the actual path which light travels through any medium, and optical path is the product of geometric path and refractive index of that medium. So the sum of optical paths will be given by S, and in case of integral, this will be written in this manner. So this is the equation that expresses Fermat's principle. Now, using this Fermat's principle, we can try to understand the laws of refraction. We know that the law of refraction is also known as Snell's law. Okay. Again, the principle is that the light will take the shortest path or the shortest time. Suppose this is the incident ray AO at a point O. Okay. And this falls on a different medium. Suppose this medium is medium 1, and this is medium 2. Here the velocity of light is say c1. Here the velocity of light in this medium is c2. Here the refractive index in this part is mu1. In this part, suppose it is mu2. Okay, suppose this medium is air and this is glass, separated by this interface. Okay, so light is incident at this point, it refracts along this point, and we draw a normal at point O. This is the angle of incidence and this is the angle of refraction. Now we measure the height of the incident ray from certain distance A and the height of this refracted ray from a certain distance B. If D is the total distance between the points M and N, and if we choose MO is equal to X, then obviously this ON will be D minus X. Okay. Now we know the time taken by the light to travel this total distance AB will be AO plus OB. But AO is traveled with the velocity c1 and OB is traveled with the velocity c2. Now what is AO? Again, as we did it in case of reflection, laws of reflection, AO is A square plus X square under root times. And OB is how much? B square, this plus D minus X square, this distance from this right angle triangle. Now total time taken is distance by velocity, distance by velocity. And again, what I have expressed previously, that the time taken will be minimum as per Fermat's principle. So dt by dx will be 0. So let us differentiate it. 1 by c1 will be a constant term. So you do the differentiation of this a square plus x square under root. So it will come down. Internal differentiation of x square will be 2x. Now here also this term will come down. 1 by c2 times, then internal differentiation of d minus x square will be twice d minus x, and then the internal differentiation of this x, which gives a minus sign. See, in the previous video where I have explained the laws of reflection using Fermat's principle, I have mistakenly put a plus sign in between, but there it is also a minus sign, and I have written that comment in the description of the video. It is a minor error there, rest it is same. So if you now simplify this equation, this 2 and 2 cancels throughout. Okay, now what is this x by a square plus x square? If you find it from this, it is sine of I, sine of angle of incidence. And what is this d minus x divided by b square plus d minus x square? It is sine of r. Okay, base by hypotenuse. So it is sine I, sine r, and c1 and c2, because they are not same, they will not cancel. Now we will multiply both sides of the equation by c. C here and C here, and we know velocity of light in air by velocity of light in any medium is the refractive index of that medium. Similarly, C by C2 will be mu2 times sine r. So this is the Snell's law that you know since class 10th level. So this is how, by using Fermat's principle, we can understand the laws of reflection and laws of refraction in a far better way. That's it.